Hello, class. Everybody quiet. Hello, class. How y'all doing? Am I on mute? No. Hello.
Morning.
All right. So somebody's out there. All right. So y'all had a good little break. Hopefully y'all fared through the weather. Made it through the weather okay. And now you're ready to get back started with the class. This is something. All right. So before we left, we was gonna complete chapter 2, and we were gonna have an exam. All right. So what we'll do that today. We'll have we'll complete that, and then I'll post the exam, and then we'll start with chapter 3. Okay. So let's look at that. Let me go back here. All right. I did post some career opportunities for you all, some research opportunities. There's 2 LSU programs that they have over the summer. There's 2 different career fairs. This one is tomorrow. So you need to log in and try to, if you want to, register for that. And then there's another one, another career fair that I posted. So you can check those out, see if anything interests you or whatnot. Okay. All right. So like I said, we're gonna complete chapter 2, and then we'll go start with chapter 3. So let's look at our notes. We're pretty much at the end of chapter 2, but I wanted to kind of complete those notes before we end it. So let's look at here. We got the comments document. Yeah. All right. So we kind of stopped in this area where we was talking about variables. All right. So now, let me move this to the side. Variables. So initializing a variable initialization. So when we declare a variable, we just giving it a data type. When we initialize a variable, we giving it a data type and a value. And that was something that we went over the last time. Give an example here. If we have, there's an error somewhere in here. If we have this statement here, int num, this is just a comment. I'll just move this down. Int num, that's declaring that num is of integer. That's all that's saying. Okay. So, and that int num, I got a main within a main. Something's wrong with this. So don't just disregard all of this. Let me just check this out. All right. All right. So int num is a declaration. All right. You're declaring that num is of integer. But if I do something like this, int num equal 81, now what I'm doing, when I declare it, I'm actually initializing it to a particular value. All right. So, and I could do that with any data type. I could say char let equals a. All right. So that's an initialization. I'm giving it a data type, but I'm also giving it a number at that same time. But if I just do it like this, all right, initializing num, but I'm declaring let, all right, to equal char. Okay, so that's what they're talking about in that particular situation. The initializing a variable, giving it pretty much a starting value. All right. Now, if you notice here, you have more than one variable being initialized. And sometimes students get that confused. I'll give you an example. If I do something like, I'll take this out, and I'll say num equal 81, x equal 5, y, z. Now, if we look at this statement, all right, we have num equaling to 81. It is being initialized because we're what? We're introducing it at the same time to be of int, but we're giving it the value of 81. X is being initialized. We're introducing it at this time to be of int, and we're giving it a value of 5. But if we look here, y is only being what? Declared. There's no value given to it when it's first introduced. The z is only being declared because there's no value given to it when it's first introduced. All right? So you see the difference between initializing and declaring. Now, some people might say, well, I can do something like num equals 81, like this. And I can do this, and I'm initializing num to be 81. No, you're not. What you're doing here, you're declaring num. You're reserving space in memory for num. But then later on, you have that reserved space. Now you're saying, assign this 81 to that reserved memory location. So here you're doing an assignment statement. Oh, excuse me, sorry. Cut this off and get out of this other thing because I think I'm still in my office hour. Yeah, okay. And turn this on. All right. So now, so at this point, we declared num, didn't give it a initial value, but then could be the next statement or statements further down in the program, we gave num a value. So here we assigning a value, all right? And even it could be something like this, x, it could be x plus 5. Whatever it is, we're assigning whatever this result is into num. Right, so that's the difference between initializing and assigning. Right, anybody have any questions about that? Okay, Anybody? Now, uninitialized variables is not. If it's not initialized, that means it's uninitialized. So if we look back at our program here, Y is uninitialized, Z is uninitialized. Now, before we can use them in an expression or in some type of output or whatever, we have to give it a value. So because if I do something like this, X plus Y, then what happens here? The computer really doesn't know what Y is equal to. So I would either have to initialize Y to be some value, or either before I execute this statement, do something like this. Y is equal to whatever number or whatever. So now what? We know X is equal to 5, and now we know Y is equal to 5. So now we can solve this and assign the value. All right? So you have to know what the value is for a variable before you can solve the expression, right? And sometimes students run into those issues, right? So, and like I say, all this does, this is kind of explain. Now you're declaring of a double or float to be test 1, test 2, test 3, and average. So all these variables are declared, right? They're declared to be of a real number, a decimal number. And what they did here, they gave assigned test 1 to equal 88. They assigned test 2 to equal 92. But what happens here? They added test 1, test 2, and test 3. But what's the value of test 3? It was never assigned. So now, therefore, your program can give you complications, give you errors. All right. Now, remember what we said about some of the watered down compilers. When you declare a variable in Visual Studio, it automatically assigns the value 0 to that variable if you don't set it to equal or assign it to equal to anything. So if we did this program in Visual Studio, we would get an average where we'd add test to test 2 to test 3, all right, which would be 88 plus 92 plus 0. That's in Visual Studio. Divide by 3 and you'll get an average. If we were to do the same exact program in Visual Studio, we would get an error because Visual Studio would say, okay, test 1, I know it's 88. Test 2, I know it's 92.5. Test 3, it's declared, but there were no initialized value, and there were no assigned value. So therefore, I can't resolve this this expression or solve this expression. So therefore, you'll get an error. So you got to watch. You got to be very, very mindful of that, right?
I have a question. Could we let them, if we let them put a value in, would that let them do that way?
All right. Now you talking about if the user?
Yes, like we said.
Right. Now that's like assigning. You understand?
Yeah.
But how would I say it? If I gave you a program and said that you ought to write this program given test 1 is equal to 5, say 80, test 2 is equal to 90, and test 3 is equal to 100. To write that program, you would not allow the students to do what? Or the user to what? Input the values, because the values are already what?
Given you.
Right. Now, but if I tell you to write a program that will allow a user to input 3 test scores, then you would have your declarations of test 1, test 2, test 3, all right? Then you would have C out, please enter test 1, and then C in test 1. Please enter test 2, C in test 2. Please enter test 3, C in test 3. So see the difference in the logic of the code.
They still have values. You just don't have initially.
Initialize. Right. Well, right. Because even if you initialize it, what you're doing eventually, you're overwriting it, right?
Yeah.
When you ask the user to input a value, right?
Yeah.
So, yeah, right. So that's the difference. Okay.
Thank you.
Okay. Now, numeric literals and data type compatibility. So let's somewhat talk about this. Now, what happens is in this, you can, in a sense, assign an integer to a float and a float to an integer variable. But what happens is, or what may happen or will happen, data may be lost in doing this, okay? So let me move this over some, if I can. Slide this over. And my screen, why can't I? Okay, slide this over. All right. So now it says many of the programs that you have seen so far, all right, have numbers written into their pseudocode. For example, the following statement, which appears in program 2-6, has the number 2.75 written into it. So set dollar equal to 2.75. We know if we do that, dollar should equal to what? I mean, not equal. Dollar should be of what data type? Should be a float or decimal. I mean, a float or double, okay? Because if I do int dollar equals 2.75, then I'm trying to take a decimal place and store it into an integer variable. All right. So it says, and the following statement, which appears in the program, has the number 100 written into it. All right. Set price equal to 100. All right. So, all right. It is most in most programming languages, if a numeric literal is written with a decimal point, such as 2.75, the numeric literal will be stored in the computer's memory as a real or like a float or double, and it will be treated as a real, right, when the program runs. Now, for a numeric if a numeric literal does not have a decimal point, such as the number 100, the numeric literal will be stored into the computer's memory as an integer, all right? And it will be treated as such. Now, it says this is important to know when you're writing assignment statements or even initializing variables. In many languages, an error will occur if you try to store a value of one data type in a variable of another data type. So what they're saying is some compilers are more strict as to what? Keeping your data types the same if I'm taking a value and storing it into another variable, okay? If that value is double or real, I need to make sure I store it into a real variable. If it is integer, I need to make sure I store it into a real, an integer variable. Now, most applications like C++, what it will do is, and let me show you what I'm talking about. What C++ will do, it will take it, and if it's an integer value, so I'll take this out and I'll do something like this. I'll say float. I'll say amount is equal to, like say we use a 2.75, all right? And we do int x. Now, if I do something like this, x is equal to amount, right? And that what the book says, what? In some compilers, if I try to do this, I'm gonna get an error because the compiler is more strict as to what type data should be stored into that integer field. In C++, it said C++ does this. It says, okay, you're trying to store this value into X. This is a real or a decimal point, a value with a decimal point. What C++ says, I'll take the integer part, put in X, and I'll truncate or disregard the decimal place. All right. So if I do something like this, C out, and then I'll do, I'll say X. When I output this, what should my output be, class? I set amount to equal to 2 point.
It'll be 2.
Correct. It will be 2. All right. You won't get an error. It'll just be 2. All right. But some compilers, they're more strict. All right. So I'll run it to show you. All right. So look what it said down here, though. It said conversion from float to int. Possible what? Loss of data. Because what? It says I'm taking that floating point value and putting it into an int value, and that int value will truncate anything that's beyond the decimal place. So it could have been 2.0000 or 2.0. It'll still look at it as if what? Some data was at the end of the decimal place, and you would have got that warning. All right? But this is what will happen. Right? You will not get an error in C++. It'll just tell you that the data will be, some data may be lost.
Right? How will you change that to decimal?
Okay. Let's get back. So you're saying how will we get the output to be decimal?
Yeah, how?
Well, you just do what?
You float.
Oh, you float. Oh.
Right. Make both variables compatible. Right.
Okay.
Now what? I'm taking a float value and storing it into what?
A float value. Okay.
Right. So now when I run it, I should get the what?
The 2.7.
Correct. 2.75.
So
see what I'm saying?
If you were writing something and you needed for whatever you were writing, say add variables like that, would you always so you can't add basically a float to an int because it'll possibly mess it up?
Well, now you're saying add. You're talking about assign it into it?
A formula with it, yeah. Like if you assign 2 different, like say amount and then something else.
Okay.
And
I'll say amount, comma.
See what I'm saying? Like
this?
Yeah, and then you wanted it to say add amount plus cost, All
right. So what you think it'll do? Well, let me take this and put it back to int. All right. So now this is int. So what would happen? It's going to add the 2, okay? It's going to do the addition, and whatever that value is only going to take what?
The whole number of it.
Correct. So this won't be 20. This won't be 30. I think it's gonna take it and increase it to 30. What? Like 31 point something. So it'll be 31. Right? It's gonna just take the whole the value of the whole number. All right. Let's see. Let me run it. All right. So you see what happened? It added them both together, 28.8 and 20 plus 2.75. That give you 31 point something. So what it did, it solved the expression and then said what? Whatever I have in the integer side, take that and store in my int variable.
Okay. So anytime we're doing something like that, we need to float.
Correct. And let me ask you this. You ever did any type of cost estimations, like computing area, dealing with concrete, or maybe a flooring or whatever?
Yeah.
Sometimes you get what? 0.5, 0.8, point whatever, and that does make a difference, correct?
Yes.
So if I would say, like, if I was trying to measure my flooring, I wanted to redo my flooring, and I did float for the length and the width, but then I did int for the area to get the total area. What would happen is it would compute everything, right? Say like when it did the formula on this side, but when it assigned it to this int value, I would lose all my my decimal side. So it could have been, I could have gotten an answer of like 25.9, right? Which would make pretty much 36. 26, my real estimate, which means when I start a job, I might come up what? Short. Correct?
Yeah.
And then if you have multiple situations like that, say if I was doing multiple rooms and I calculated each one of them separately, say like if I had 10 rooms and all of a sudden now I'm storing that value in the integer, I might be what, 10 square feet short, which means that may be a whole room I done calculated to be short, right? So it does make a difference. Sometimes you may want to truncate the ending part. You just want the whole number, all right? Sometimes, depending on what the scenario is when you're writing the code, all right? But you do want to keep in mind when you writing code, if you want to keep that value, make sure that your data types do match, and it'll resolve your issue. All right. Now there's something called static. What is called static cast, but that's in the next next class, like 193, where you can have something declared as int, but do a static cast where you can temporarily convert it to a double to do what you need to do with it, and then it doesn't change the fact that it's int, but it allows you to use it as a double and return back. But that's in the next class. All right. Any other questions? So you could get errors when you're dealing like this, all right? And that's what this telling you. But most programs, it may not give you errors, they just truncate, right? Most programs are not allowed, and that's all it's saying, to you to assign real numbers to integer variables. But we just saw that we could. Only thing happens is it truncated, right? Even though numeric literal 77, all right, is treated as an integer, it can be assigned, all right, to a real variable without loss of data. Now, why would this statement be true, class? Well, why can I take the number 77, which could be of an int variable, and assign it to a real variable, a float or decimal variable, and not lose any data? Why is that? Because 77 in decimal is 77.0. So there's really nothing being lost. So that's all they're saying here. All right. So giving you this example here. Go back to here. So what they're saying is this: if this was equals 77, all right. So, and I'm gonna just overwrite a value here. So if I said amount is equal to X, so now I'm taking an integer value and storing it into what? A float variable. But what happens? I don't lose any value because what? 77 in integer, if I convert it to a real number, it's 77.0. So it's nothing being lost. Everybody got that? That integer value turned into a real value, you just do the 0.0, and 0 is nothing. So that value is not really being lost, all right? So you're not really losing anything, all right? So now I put an amount here, and I should get the value, all right? It should come up. I clicked the wrong one. All right. So here we got 77. So what it did, based on it being 77 integer, it stored it as integer here, and it printed. All right. So now what I'd have to do is use my format and that's using another header file, which we won't talk about. All right. So let me close it and run it again. All right, debug. All right. So here we got 77 because what? It returned that integer value 77 into here. All right. And many times, like if I did something like this, 77 comma y equals, I'll say 3. All right. Now, so if I do something like this, amount is equal to x divided by y. Now, 77 divided by 3, that's going to give you a number with a decimal place, correct? Now, later on in, as the next chapter, not the next chapter, but the next class, they talk about the hierarchy in your processes. So what happens is a promotion and demotion. What happens is we have an int divided by int. Int divided by int will yield an integer value. So whatever is going to be stored in amount, it should be an integer value. So if I run this, all right, if I go to debug, it's going to yield an integer value. I know it might be float just because of the float. Where's the value here? All right, yeah, okay. What happened is it did the float because it stored a decimal place in here. But if the number came out to be a whole number, it would have gave the whole number. In order for me to get the int value, I'd have to put 0.0. So like say, if I do this 11, all right? If I run this debug, I should get 7. All right, see, I got 7. Now, watch what happens when I do 0.0. Now, when I do the 0.0, it should do, well, it may not, but it should do, no, it didn't. It didn't promote it. It should have did the 0.0. But normally when you have a integer divided by a float, it'll result into a real number. All right, but this is a real anyway because it is of decimal because it's a float. All right. Now, and I think we'll look at this further on in the chapter, the promote and demote. All right. So just remember though, when you're converting a whole number into a real, you're really not losing anything because you're adding what? 0.0. All right. And here we go, integer division. 3 divided by 2, that should yield a whole number. All right. So what happens is it's telling us this statement divides 3 by 2, 2 going to 3, 1 point, 1 point whatever times, and store the result in the number variable, which is the number variable here. All right. What will be stored in number? Now, it should have been, okay, 1.5. But we saw when I tried to do it, it did the decimal. All right. You would probably assume that 1.5 would be stored in number. All right. Because its value, all right, is calculated and well, because that's the result. Your calculator shows when you divide 3 by 2. All right. However, it's not what happens in many programming languages because what? The numbers 2 and 3 are both treated as integer because there's no what? Point whatever, no point whatever. The programming languages that you are using might throw away the fraction, all right, part of your answer. All right. So what happens here, it should have, but it didn't do it when I did it. But let me do 3 by 2. 3 divided by 2. Now, 3 divided by 2, it should give me the 1. It should only give me 1 because they both, like I was telling you before, they both are integer. Okay, it gave me the 1. Now, if I add 2 point, and why I didn't do it with the 11? Because 11 was integer. I don't know why I didn't do it. All right, so now if I divide 3 by 2.0, now amount will equal to 1.5. For the simple fact that I'm dividing a integer by a real number, which promotes the results to be of real, and now amount will be equal to 1.5. By me, let me go back. By me simply putting the, see here? Same program. All I did was what? Made this 2.0, and then now it stored the 1.5 into the amount. But if I go back here and make this 2.0, well, it's gonna say, okay, int, so store int here. So it's gonna only store what? The 1, okay? And when we click here, see, only the 1. And we really know that what? 3 by 2 divided by 2 is 1.5. All right. So there's some little tricks you got to watch when you're coding, because what? It can throw your results off if you're not paying close attention. So that's all this part is telling you. Okay, if I have an integer, I might lose some data if I don't put 0.0 in here somewhere. You know, especially when you divide. All right. Especially when you divide. Now, name constants. Constant. All a name constant is a variable that's created that cannot be changed. All right. So here, if I do something like const, that's the command, and I'll say total. All right, and I'll just say AMT. AMT is equal to, I got to do a data type. Cost, whatever data type. If I say int, or I could use float, whichever type data I'm putting in, I'll say float, and AMT, the variable, is equal to 2.83. All right. So now, what I have here is a variable called AMT that wherever I use it in the program, it will always equal to 2.83. If I try to change the value by assigning a different value to it, I'm going to get an error. Give an example. If I do this here, say AMT is equal to 1. See, it give me an error. But watch here, I'm going to run it and I'm going to show you what the error it gives. All right, no. And look, it says AMT, you cannot assign a value, you cannot assign to a variable that is constant. So once you make a variable constant, it's that value throughout the program. You cannot assign anything to it, no matter what. You cannot do it. I'll give you an example. Many people, you've used math. The pi is equal to 3.14 in short, right? If I was writing code to where I was calculating area and some other circumference of a circle, not area of a circle and whatnot, I would be using pi in my formulas. Now, if I wanted to, I could in my program say, okay, const, and I'll say float, and I could say PIE, because that's a correct variable, is equal to 3.14. So now what? If I could tell you. Now, everywhere I use pi, the value pi is equal to what? 3.14. Now, anywhere in my program, I cannot change pi to equal to anything else. I set it equal to this, and this is what it's equal to. All right. So that's what a constant variable is. All right. You set it to a value, and it does not change. All right. It stays the same. It remains the same throughout the program. All right. So if I try to change the value, such as what I did here, I'm gonna get an error. All right. Okay. Now, any questions about that? Constant variables. So what happens once you set this? This looked like they was trying to do something, and this was a particular tax, like what? 6%, 6.9% tax. No, yeah, percent tax. So what they did, well, they used it in a statement. But what you can do is you can make interest rate of constant, of a real data type or float data type, and set it to equal to 0.069. And so anytime you want to use this interest rate here, all you got to do is what this variable called interest rate, all right, in your program. And it's set throughout the program. You cannot change it, right? Cannot change what it is. So it's equivalent to doing this. Amount is equal to balance time 0.01069. Or you could do amount is equal to balance time interest rate, because we set it to equal to what? 0.069. So same difference. Okay, questions? All right. So here they set an interest rate to equal to what? 0.072. So that means anywhere in the program they use interest rate. Now this program, it'll be set to 0.072. All right. A name constant cannot be assigned a value with a set statement or an assignment statement. That's what they're saying. Okay. If a statement in a program attempts to change the value, which we saw with the error, of a name constant, an error will occur, which I showed you in that program. All right. This is a debugging technique that would be helpful in trying to find out exactly what is going on in your program, where it's happening, and even keeping tallies of values as they change in the program. And it's called hand tracing, right? And all you're doing is going through the program, and as you hit an assignment statement of declaration or initialization, you actually writing down what each variable is equal to at that time. And it just allows you to track, what's going on in the program. All right. So hand tracing is a debugging process where you imagine that you are the actual computer itself. You're going through the program and executing it yourself, line by line. Okay. This process is known as desk checking. All right. You step through each of the program's statements one by one. Okay, as you carefully look at the statement, you record the contents that each variable will have after the statement is executed. So when you get to a statement, okay, what's involved in this statement? Is it an assignment? Is it a computation? Whatever. I need to evaluate what each variable is at that time. And you go on and on and on until you get to the end of the program. All right. So it say to hand trace a program, you construct a chart. So what it is, this chart has what? Every variable that's in this program. So what happens is, if you look at this, okay, the first statement, okay, test 1. So test 1, there's no value. Second statement, test 2, there's no value. We just declaring. Test 3, there's no value. Declare average, real, no value. So for the first 4 processes, there's no value attached to these variables. But then when we get to line 6, it says test 1 is equal to 88. So what you would do, you would write 88. Where is that? 6, right? Here, this is still nothing. This is nothing. This is nothing. All right. Then line 7, test 2 is equal to 92.5. But what? Test 1 is still equal to what? 88. So you'll put the 88 and then you'll put the 92.5. These are still nothing. Right. Then you get to 8 and you see set, which would be an assignment statement. Average is equal to test 1 plus test 2 plus test 3. So Test 1, we know what test 1 is. Test 2, we know what test 2 is. Oh, test 3, we really don't know. Some compilers will what? Still perform the task. They'll assign a 0. So then you put that 0 there, and then you what? This plus this plus this divided by this. Oh, that's giving me my average. And then in the last one, for the average, what test 1 is equal to, what test 2 is equal to, test 3 is equal to, and average. All right. So that's basically how you would go through the hand checking. And if you look here, remember the first 4 or 5 statements, all this is unknown because what? There's no values attached to any one of these variables until you get to 6, where you're assigning 88 to test 1. Then you're assigning, even though you didn't assign 88 to test 1 in line 7, test 1 is still at that moment equal to what? 88. So that's why you see the 88. You see in that what? In this program, once I assigned it to 88, what? It never changed. I assigned test 2 to 92.5, and what? After that, I never assigned it a different value. All right. And here, depending on the compiler, C++, you can't do this because you have to know the value of a variable if it's in an expression, and therefore that's why they wrote undefined. You cannot solve the problem because test 3 did not have a value. Okay, so that's what this hand checking does. You write down all the variables, and then you go line by line checking to see what a value is for a variable, when it, and if it changed, what the value is, and you can kind of keep track of what's going on. And that like you the program, you the computer, all right, trying to evaluate the program. All right, program documentation. There's 2 ways to document a program. You could do it internally with comments, or there's the external documentation, which would be like either online help or documentation hard copy. All right. So in short, internal documentation, if we go back to this, what I can do is, and many of you have done it, all right, like you could do a / and which is a comment, this program will, and ... And you can explain what it is. If you got another line, you can do / and then whatever it is you want to say, as many times as you want. All right. Each line that has a / is a comment. Now, I can also comment a line at the end. All right. So, like, say for instance, pi here. I can go to the end of the line and say // So now everything from this point on is a comment. I could say pi is being used to calculate, and whatever. You understand? So I could write out what it is that particular statement is doing, what that particular variable in that statement is doing, what the value is being used for, and why. So I can actually document. So if somebody come behind me to look at or to modify the program, they have some little notes to follow and to know what they did, why they did it at that time, and whatever. All right. So that's one way of using comments. Now, another way of using comments, if you notice here, I got what? // and I could have had some data here. And I'll just put ... to say, well, it continues. All right, ... So, but what you could have done is said, okay, rather than trying to put a / in front of each line, and I could have had 100 lines, I can actually do a block of comments. I could do the * and */. All right. Now, what that says is, I need to do it at the end. Okay. */. I can type. All right. So what they're saying is everything between this slash asterisk and this asterisk slash does not execute. Okay, that's just the comment. Now, some programmers, I do it at times too. When you're coding, you might have a block of code that you're having issues with. So you might say, well, I don't want to execute this block of code. So I'll put a slash asterisk asterisk slash around that code so the program can go on and execute the rest or the other parts of my program. And then I could always come back and fix this or do whatever I need to do, and then remove the comments off. All right. So sometimes it's useful in debugging too, where you can comment something out, run the program, see what you get, then put it back in, and then try to fix the program. So you got the slash slash for a single comment, and then you got the slash asterisk asterisk slash for a block of comments. Because I could take this and notice what happens. And I could do asterisk slash. Now, my whole program, except the last curly brace, is commented. Okay? So everything is commented except the last curly brace. All right? So those are the two ways you can comment. Now, then there's a hard copy. Now, the hard copy of documents could be a user's manual. It could be a listing of all the variables in the program that you're using, their data type, and why those variables are being used. It could be any substantiating documentation for the program. All right. So it just tells us, see, slash slash, comments a line. A block of commented lines. Okay, rather than do this, you can do what? Slash asterisk. Where is it? I'm looking for it. It's not showing it. Well, you could have done the slash asterisk, and then at the end of it, on the blank line, asterisk slash. Not at the beginning. The ending is the asterisk slash. All right? So there's several ways you could comment any way you want in your program, throughout the program. Some people comment so much you can't see the code for the comments. All right? But like I say, it depends on you and how much you want to keep in your code. How many comments you want to keep in your code. But the codes can sometimes make your code look confusing if you don't know what you're looking at. All right. So I think designing your first program. All right. Sometimes as a beginner, you might have problems getting started. You always know you use the terminal when you're doing sort of your flow charts. All right. In this section, we will present a simple problem. Okay. Go through the process of analyzing the program's requirements and design the algorithm. All right. In pseudocode and flowchart. So it's going to take a program and go from start to finish. Okay. So it says, okay, batting average. Now we know a batting average, you would take the number of times at bat, hit, and divide it by the number of times you had an opportunity to get a hit, or the times at bat, to find out the average time you got a hit. All right. So in baseball, batting average is commonly used to measure a player's batting ability. All right. You use the following formula to calculate a player's batting average. Batting average, okay, is equal to hits divided by times at bat. So in the formula, hits is a number, all right, of successful hits made by the player. So see, that could be a comment when you start writing your code, when you do int hits, and then and you could put slash slash the number of successful hits made by a player. So see how you can write your code to where you got your comments in there based upon the instructions that are given. All right. Times at bat is the number of times a player was at bat. Same thing. Do your declaration and then slash slash at bat and your comment. Now, It says, for example, just letting you know how it's done. For example, if a player is at bat 500 times for a season and gets 150 hits, all right, that player's batting average is 300, all right? And they did .300, but they call it 300. Now, so what they did, they took 500 divided by 150, and then they got the 300, okay? It says design a program to calculate any player's batting average, all right? I don't want to mess up the time. Let's see what time it is, because I know. Okay, got time. All right. Now it says, so what we want to do, we want to decide how we're going to write this code. Okay. So how will we write this code? All right. First of all, we got to find out what are all the data that's known. Okay. If we write in the code, and I think one of the students asked earlier in the class, oh, well, what about asking the user to input the information? That could be one way if the information is not already known, okay? So it says input is received. Now, like we said, how is the input received? Is the data given? Is the hits known? Is the at-bats known? All right. Is the hits going to be inputted by the user? Is the at-bats going to be inputted by the user? So that's something we're going to have to know before we get started. Now, some process. So once we get the information, we're going to have to what? Calculate. We're going to have to write the expression to get the batting average. So what? Hits is a variable we're going to need. Whatever we name that variable, we could call it H, we could call it hits, we could call it HITS, all right, we could call it HS, whatever, as long as it's a valid variable name and you understand and know what that variable represents, all right? So hits, and then that's one variable we need. At bats, or times at bat, that's another variable we need. And then you could call that at bats. You could call it AB. You could call it TAB. You know, whatever you want to give it. You know, you as the programmer have the flexibility to give it whatever name you want to give it. As long as I say, if you know and can remember what that variable represents. So, and then there's one other variable that we know is unknown, is the what? Batting average, because that's what we're trying to what? Calculate. So we're trying to calculate the batting average. So we got the hits, the at-bats, and the batting average, all right? So in all that, we need to produce some output, and the output is the what? Batting average. So now you got all this in your mind. You got to be able to take this and say, now let's put this together to write the program, all right? So it says your first step is to determine what is required, which we've already done, the bat hits, the batting at-bats, and then determine the batting average. So input is received, all right? So determine a programmer's input requirements. Now, whether or not they're going to what? Input it, or where it's going to be given, all right? If you look at the batting average formula, all right, we see that two values are needed to perform the calculations, or really three, but two of them to actually execute, to start it. You need the hits and the at-bats, and then what? To be stored into batting average. Now, it said, now look at it, because these values are unknown, see? So now we kind of getting to understand how the program is going to be written. Because the values are unknown, the program will have to prompt the user to enter the values. So now we know that what? We're going to declare variables, and then we're going to say, please input the number of hits. Please input the number of at-bats, and then calculate and then output. All right. So that's what I'm saying. It's good to know exactly what you need to do before you start writing the code. So now some process, okay, so something gonna have to be done. We're gonna have to calculate something, all right? We're gonna have to calculate the hits plus the at-bats, hits divided by at-bats to get the batting average. So once the program has gathered the required input, now what? It can proceed to use the input in any necessary calculations or other operations. So you can do whatever you got to do with it once you collect it. All right. So keep in mind that when a mathematical calculation is performed, you typically want to store the results, all right, of the calculated calculations in a variable. And now this particular statement, what they're saying is, and I'll show you here, and some people code that way, but we try to get you to store data into a variable rather than output it. Just straight output it. So look at this. So say we do this, we do float, and we're going to do those batting averages. We do 500 and we do 150, right? So what I can do is I can go here, and rather than take 500 divided by 150 and store it into a variable, I could do this, 500 divided by 150. So what happens? Rather than me create, that's my fault. I want to do X and Y. X divided by Y, right? Which is still 500 divided by 150. So what? Rather than me create a variable to store the batting average in, right here, I'm gonna just output the batting average. Just say AVG. So now if I do a debug and I run this, it's gonna give me, it's gonna give me this answer here. So notice what happened. I didn't have to store it into a variable, all right? It just gave me the answer, all right? But did I do that right? I think I did that wrong. I did this wrong, class. I did this wrong. It's Y divided by X, because I put the values in. The at-bats is 150, and the number of time. The at-bats is 500, and the hits is 150. So let's run this. Now, and see, we got the average. You understand what I'm saying? But the thing is, if you wanted to use this value again somewhere in your program, you would have to redo this formula in your program. If you assign it to a variable, then you can take that value that's in that variable and use it wherever you want in the program. So we try to get you to do it something like this. I'll just say BA. So we'll just do something like BA is equal to, which would be batting average, is equal to Y divided by X, all right? And then, so now you have BA. Now you could print BA, use BA anywhere in the program. You don't have to recreate X divided by Y, and then you just print out BA, all right? So we normally want you to store the value in a variable and then print that variable out, okay? Now, is it wrong to do it the other way? No, it's not wrong, but we just like for you to do it that way, all right? And what? We get the exact same answer. Exact same answer. All right. Now, okay, so you produce the output. Now, in producing the output, you need to know how the output should be printed. What are the output labels? How do they want to print? They want to say the batting average, or your batting average is, or just say batting average, or say something like great batting average, whatever. So you have to know how the output is to be presented to a user on the computer, so that you can write the code accordingly. All right. So you have to decide how the output is going to be, and then produce that output. And there was the other class. But like I say, the spacing in between words, spacing in between words and the values, things of that, punctuation, all of those things are important when you communicating with the user. All right, so your output need to be legible, not readable, so that it is easy to read through. All right, so now look at this. They say, okay, they got to declare an integer variable called hit, declare an integer variable called batting average, at bats, then declare a real variable called batting average. All right, now once they declare these variables are known within the program. Now they need to retrieve the data, enter the player's number of hits. Then what? Input hits. Okay, hits is a variable. Enter the player's number of times at bat. Input at bats, which is the variable at bats. And then after you got the hits and the at bats, now you got to calculate, which is a process, the batting average. So what? Batting average is equal to hits divided by at bats. And then once you calculated the batting average, you want to display your data or the output, and the player's batting average is in the space, and then batting average. All right. So you see the things we have to go through. Read the problem. Determine what it is we need to do. Determine the different data, the variables that need to be used in the program, the input. Then determine the process, what we need to do once we get the values, how we're going to calculate them. And then once we do that, how we're going to output the data. So all these steps, like I say, you need to follow through. So what? Most times you don't have to go through those steps over and over and over and over because you missed something. Oh, I misunderstood this. Well, let me go back because I misread this. So if you read through it, write it down, go through the process, it'll limit the number of times you have to try to repeat the processes. All right. So look, declaring the variables, then what? Output, please, and a number of hits. Input the hits. Output, please, and a number of times at bat. Input that bats. Then calculate the batting average by dividing hits by at bats, and then displaying the prompt, and then the batting average, and then end. All right. So that's the pseudocode. So this is normally the process that you should follow every time you have a program to write. And so that what? You can go back and reference your notes as to, okay, let's see what he said, how we, whatever. Let me see what variable names I said I was going to be using. Let me see the logic that I was using at this point or whatever. So you have this substantiating documentation so that you can use to do your program. All right. So that's the chapter. All right. So what I'll do at the end of the class, I'll post the quizzes and was a quiz, one quiz, and then the read chapter quiz, and then the test. All right. Now, the next chapter, I'll just kind of introduce it to you because it's a little. Well, we could kind of go over it. We got a few minutes. Modules. Now, how would I try to explain modules? All right. To me, one way of somewhat giving you a concept of what modules are, it's like taking a house. All right. When you build a house, more often than not, a conventional house, a house have what? Multiple rooms. All right. When you write a program, most times when you write large programs, you write a program with multiple sections, all right? Bits of code that can execute independently. That's modules, all right? Each module should and can run independently of the main module, given some little quirk in the program. But you have a house where you have a living room, you have a kitchen, you may have a den, you may have a restroom. So each one of these rooms have a purpose, all right? In your program, you have the program, but then you have modules, and each module in that program has a purpose, but they all together work to be called a program. Just like all the rooms in a house together make the home. All right. So that's one way of kind of putting it. But let's look at what the book explains it as. A module is a group of statements that exist within a program for the purpose of performing a specific task. Okay, give me an example. If you were writing a program and I told you I wanted the header, well, look at the header file. You have a header file that's gonna give me your personal information of and about the program, your name, the date of the assignment, the name of the program, the date it was due. Okay, you could create a module. Okay, that does that. You don't have to put that in the program. See out this, see out that, see out that. No, you create the module that does the see out whatever, and then you call that module. And give you an example. Most no, you all didn't do it. We don't do it in this class, my other class. But so the module have specific code code that does a specific task. Now, you might have a module to do your personal information. You might have a module that collects the data. You might have a module that calculates the data. You might have a module that outputs the data. So what happens is I have this one big program and I have 4 modules, a module for my personal information, a module for my input, a module for my process, and a module for my output. So what I've just done, I've just broken down a program in 4 different parts and they all work together to make that one program. All right. So that's how modules work. All right. So if we scroll down, if we look here, it tells us that this approach sometimes is called divide and conquer because what? A larger task is divided into several small tasks or smaller tasks that are easily performed. All right. So what happens here, the benefit of modules simplify the code where all you see is maybe an abstract part of what it's doing, but then you could go look at the code and see what it's actually doing. You can reuse code. You can call that code as many times as you need to and don't have to try to keep, I got to copy and paste the code, copy and paste the code, copy and paste the code multiple times. No, you just call the function. All right. And it allows you to, it reduces the number of lines of code and which allows for a better way to test the code. You always comment out a call, you don't comment it out a whole group of statements rather than having to go through it and try to test each line. Oh, I removed that line out, I could check it, do whatever. So it kind of gives you a better way of fixing your program. So this is just a picture example of what they're saying. If you can write a program, because what? Modules are not necessary for a program to run, no. But it helps in that it makes the program much clearer and much easier to understand. Example, you could write a program from start to finish, line by 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 line. But dependent and given, we've never done if statements or while statements yet. And when you start putting those things in a program, that can make your program very, very, very confusing. All right. But what you could do, okay, well, these first 3 statements, and like we was talking about, these statements output my personal information. So let's take these statements, put them in a module. And all we do is have a call function to call that module to execute it. These particular statements, they perform the input. So what we could do, we could take those statements and put them in a module. And so now you see how what we're doing, we're taking one long program and splitting it up into small parts so we can look at the program in a more abstract way, but it's more clearer. So that's what it does. Now, it says faster development. Now, what that means is if I had the class and I said, okay, I'm gonna break you all up in groups. Okay, group one, you have the responsibility of creating the first module. Group two, would be the personal information module. Group two, you have a responsibility of creating the input module to input all the variables in the program. Group three, you have the responsibility of creating the process module. Your module going to process all the data that's accepted and doing all the calculations. And then group four going to be doing the output module. So they're going to be responsible for the output layout and how the data should be outputted. Now, so when it say faster development, what happens is I could assign all four of those modules to be done at the same time. So what? All of them are being processed equally at the same time. But if I gave you the program to do and you had to go from start to finish, you had to first what? Try to start doing the personal data. Then after that, then you have to try to do the input. Then you have to do the next one. So you're doing them what? After the one is completed, as opposed to all of them being completed at the same time. And this is how a lot of times projects is done in corporations and on a large scale. You have teams working on different modules, and then once they complete their modules, they put them together as one large program. All right? So, and either facilitation of teamwork. And like I say, you can just give each team a task to do, and they could work on it and then come back, put it together, all right? Defining and calling a module. Modules have names just like variables have names. Oh, class is over. All right, I don't want to go too far. So modules have names just like variables have names. And on next class period, what I'll do, I'll show you how modules work, because what happens is with modules, if I can, let me see something. Yeah, okay. What happened with modules, I'll show you this right quick and then we'll go. Look at this. This is a module, this is here. So see, I have this. This is something that's written, a function, which is a module, all right, that is in another program. But let me show you what happens here when I run this program. If I can get back, okay, let me get back to the program. So in this program, all right, what I can say is I want that information here. So I know, if I could tell you, all right, so here, what I've just done, I've just called this module into this program, and when I execute this program now, it's gonna do what? It's gonna go here and it's gonna give me 4 new lines, and then it's gonna tab twice, it's gonna output header file, ... and then 4 more new lines, and then it's gonna return back to the program, and then it's gonna assign amount to be constant to equal to that, assign pi to be constant equal to that. It's gonna assign initialize amount and cost, and then it's gonna initialize X and Y, and then declare BA, and then calculate BA by dividing Y by X, and then printing out this. So if I run this time, debug, and I run it, notice what happens. See what happens? Header file, and then batten average. So what did I just do? I took a module and called it into this program, and it ran. Now, I'm gonna show you about that module. I could take the information in this module. Remember I told you it should be able to run independently, but now I could take this information, I could copy it and go back to my program here, take my module off, and I could just put that statement here. Now I don't have a module, I have that statement. I'll run the program and I should get the exact same results. if it comes up. Did it come up? Let me see something. Let's see. Oh, okay. Let me see. Debug. Yeah, see, I got the same results. It executed this output, and it executed that. But what? With the module, this output, and like I said, I could have had more than one CL was in another module. All right, so I'm gonna stop right here. What I'll do after we finish, I'll add. Well, I'll go ahead on it. Add the test and the quizzes so that you can take those. And like I say, read up on chapter 3 so that you'll be abreast of what we're going to go over on next class period. All right. Any questions?
What's the due date for the test?
Test will be next Monday. Like normally I give you that week, no, right?
Okay.
All right, I'll give you a week to do it from today till the day before class. All right?
Okay.
All right. So I'm going to go ahead on and set that. And if there's no questions, y'all have a good week. All right? Let me open it. Okay, let's see. Yep. Today, the 23rd. Okay, publish that. Okay, the quiz. Try the quiz. Okay. Okay. And then the 10th. What they say? Okay.